In this video tutorial, we will show you how to configure the SBG Ellipse for your Airborne application. This is a critical step, as if the ellipse is configured incorrectly, the resulting data will not be usable. The first concept to understand is that all measurements need to be made in the aircraft coordinate system, which is defined such that positive x is the forward flight direction, positive y points toward the right side of the airframe, and positive z is down. The second important concept is that measurements always start at the ellipse and end at the point of interest. In this case, the center of the antenna or the center of the imager's objective lens. The origin for measurement is a point inside of the ellipse, shown in the graphic here. For our purposes, we can approximate the location of this point as just above the letter B and 1 centimeter from its base. If you have a 3D model of your drone in installation, you can pull the measurements from that model. If needed, the details of the origin point are included in the Ellipse user manual. With these concepts in mind, we will first measure the main lever arm, which is the distance from the ellipse to the center of the imager lens. It is useful to have a measuring tape marked in centimeters for this task. Measure from the origin point of the ellipse to the center of the lens. Do this for all 3 aircraft coordinates, x, y, and z, and write down the results. Also note the orientation of the ellipse relative to the direction of flight. In this case, the y-axis on the ellipse points backwards and x points up. The second measurement you need to make is the primary lever arm, which is the distance from the ellipse to the GNSS antenna. This can be a difficult measurement to make accurately, but try to measure to within a few centimeters. If you are using the ellipse D, you will need to measure the distances for both antennae, labeled number 1 and number 2. With these measurements made, we can configure the ellipse. First, connect the ellipse directly to a laptop that has SBG Center software installed using a USB extension cable. Once connected, launch the SBG Center software. First, press the Connect button, followed by the Refresh button. If the software prompts you to reconfigure the serial converter, press the Yes Please button, followed by the Yes button on the preceding dialog. Then press OK. The ellipse should show up in the selection dialog. Highlight it and press Connect. Next, press the Configure button. In the Motion Profile tab, select the Rotary Wing UAV as the selected model. Then press the Alignment and Lever Arm tab. In the Device Rough Orientation field, select the direction the X and Y axes labels on the ellipse point relative to the direction of flight. In this case, the Y-axis is pointing backwards and the X is pointing up. Next, enter the measured distances for the main lever arm. When finished, press the Aiding button. Enter the primary lever arm measurements that were previously measured from the ellipse to the antenna. Leave the box below unchecked unless you are confident in your measurement to within 1 centimeter. Once finished, press Save and exit SBG Center. Your system should now be installed and the GPS IMU configured. The next step will be determining the flight parameters, creating a target area, and making a flight plan. These topics will be covered in another video. Thanks for watching. Check out Resonon's YouTube channel for more videos and subscribe to stay up to date with new content.